Good morning and welcome to my channel. My name is Aryan Singh Rana and today I'll be showing you the solution to today's tree question with the lead code number 1481 and the title is least number of unique integers after k removals. So the question is of medium difficulty level and the question is like this. Given an array of integers ARR and an integer k, find the least number of unique integers after removing exactly k elements. So the question is pretty simple. It is simply asking us that we have been provided with an array and an integer k, and it is telling us to give us the least amount of unique integers after k removals. Now, what does that mean is that after we have been provided with the integer k, we have to perform k operations, and to be specific, we need to remove k elements from the array. And the array after the k removals, k, or you can say after we have removed k elements k times element, then the array should have least amount of unique integers. Now, unique in the sense it is saying that there should be much more less amount of different type of integers. For example, for example, we have been provided with array like 1, 2, 3, 3, and the k is 2. Now, as we know that the different type of elements inside the ARR is 1, 2, and 3. So we need, and we have been provided with the k element as 2. So it means that we need to do two removals. So the and we need to find the least amount of different type of characters. Now, if we remove both of the threes and after both of the threes, then it would be count as elements two elements have been removed, and the answer array would be remained like 1 and 2. Now, it is not the least amount of unique elements because as you can see that one is different and two is different. But if we remove 1 and 2, then the answer array would only consist of 3 and 3, and we know that 3 and 3 are of same type, or you can say they are the same number. So the least amount of unique integers after k removal will be 3. If we remove elements like 1 and 3 or 2 or 3, then in both the cases the answer would be like 2 and 3 or 1 and 3 respectively. And in both the arrays, as we know that there are two different elements, so the least unique number in that case would be 2, and it is not a correct answer. So that's how the question is asking us for to do everything. Now let's come to example number 1 to further understand what we have to do. Now, as you know that as you can see that we have been provided with an array 5, 5, 4, and the k integer is 1, which means that we can do at most one removal. So as you can see that the output is 1 over here. Now, why is that? Because if we remove 4 from the array, then the only type of integer that is left inside the array is 5. If we remove 5 instead of 4, then the only types of integers that would be left in the array would be 5 and 4. And the number of different types of integer inside the array would be 2. So that is not a correct answer because that is not the least possible outcome that we can get. The least possible outcome that we can get is 1, because as I mentioned in the first solution or first step, if we remove 4, then the only type of integer that would be left inside the array would be 5 only, and the output is 1. That's why the output is also showing over 1 over here. Now, coming to the example number 2, the following array has been inputted in our method, and with the integer as 3 is equal to k. Okay, so it means that we can do at most 3 removals, or we have to do 3 removals, removal of 3 elements from the array. Now, what can we do? Now, we first now for example, let's say I remove first three elements, which is 4, 3, and 1. Now, these are the selected elements that I would remove, and the selected element number is 3, and which means that I have removed 3 elements. So we cannot further remove any other elements. So the remaining elements would be these 4 over here. Now, as we can observe that the number of different types of elements within the ARR is 1, 3, and 2. So it means that we have three types of different integers, and that is not the minimum possible least type of integers we can possibly get from this array after three removals. So the most optimized removing from this array would be if we remove we remove 4, then we remove 2, and then we remove this 3 or one of the threes. Then what the array would only be left with 2 1s and 2 3s. So in total 4 elements, and the different type and the type, you can see that there are only two different types of elements inside the array after three removals from the array, which means that this would be the least least possible different type of integers available or left after the k removals. So that's why the output is 2 over here, which indicates there are two different types of elements left inside after k removals. So that's how the code is. Now coming to my solution. Now let's first recapitulate what we have observed from all the examples. Now we know that we are removing the least frequently arriving number inside the whole array. Now why are we doing that? Because if we remove the most frequent number or the number which is arriving multiple times in the array, if we reduce its number, then it would left out the different types of integers that we could have removed, and it would reduce the different types of integers that are currently available in our array. Now, let's take it like let's do the example like this, okay? If we do, if there is a there's a array like 1, 1, 2, 3, 4, like something like this, okay? And the k amount of the removals that we can do is 3. Now, if we remove the element that is frequently occurred, then what would happen is that if we remove like these ones over here, now this one and this one and this one. Now we have removed three elements from the array. Now we can see that the most different types of integers inside the array after k removals is 3, and that is not the correct answer. The correct answer is 1. Why is that? Because if we remove the most least frequently arriving or least frequent integers from the array, then what would happen is that let's see, now the most frequent element inside the current array is 1, and the least ones are 2, 4, and 5, because they are arriving only one times in the array. Now if we remove this, so first we remove 2, then we remove 4, and then we remove 5. Okay, so now as you can see that the array would be left with only one type of number. And that would be 1, 1, and 1. So the output would be 1 over here, and this is the correct output. So it means that to occupy the after the k removals, we need to let the numbers that are arriving most frequently or have the largest frequency in the whole array. We won't remove any elements from that if necessary, but we will definitely remove the elements that have the very less frequency or arrive only once or less than the most frequent one. So that's how the whole code is running. That is the main source of my whole code. So let me just show you the example that I have created. First, I counted the number of, or you can say I did a frequency counter for each and every element inside my array. Now, what hash map is storing? Now, HashMap would store the different elements in the key position, and the value would signify the number of times that key value is arriving inside my array. So it is a basic frequency counter. As you can see that first I used a for loop to iterate through each and every element inside my array. This is the most generic for loop that you would know. So I will not explain each and every command in this, but I will explain this one. Okay. Now map.put, now, which map dot put inside the array, it says that the element at the ith index inside the ARR, comma, map dot get or default inside the bracket, element at ith index inside the ARR, comma 0 plus 1 outside the parenthesis. Now, what does that mean? Now, as we know that map dot put is the command to either create a new key value pair or to update the existing key value pair. Now, the map dot put, what would it would do? It would first, if there is a key that is already existing with the value of with the value equivalent to the element at the ith index inside the ARR array, then it would update the array value by get first. It would update the value of the key by first getting it. So what this map.get or default does, that it first takes the key as the input, and it returns if there is a value associated to key, or if that key value pair already exists in the hash map, then it would return its respective value. If that specific key is not, or that specific key value pair is not there in the hash map, then what it would do, it would return the default value that we have mentioned now after the comma. So this value, which is zero. I've currently mentioned zero, so it means that if there is not a key or it cannot retrieve a value associated to that key, then it would by default return zero. If I write something like one, two, then it would return one or two. But in our case, I will return is zero. After that, what we are doing, we are simply adding plus one because it means that we have encountered another one or it is a first of its kind. Now, why you must be wondering why I'm initiating the counter as zero or not. Why not one? Now, if the key already exists, it means that we have already encountered it once, and this get function, get or default function would trigger, and it would return its respective value, and then it would add one to the value, and that this parent, the most outermost map dot put would update the value of the current key with the value or with the value is equal to value plus one. So it would give this command would give us the respective value of the key and it would add one to it and update it. But if there doesn't exist a key value pair with the key as the current element or the as the current element we are iterating on, then what would happen is that first it would create a new key. Then this get or default map dot get or default would give us the zero value because the key value pair doesn't exist and the value would be zero. Now, 0 plus 1 is 1, which means that we have encountered our first element inside the first unique element inside the array that we have not registered inside our hash map. So it would create would create a new key value pair like for as the key name map would create a new key value pair and the key would be the current element we are iterating over and plus 1 or 0 plus 1 which is 1 as its value. Now then I created a list of data type integer, and I mentioned it like ls. The name of the list is ls. Now, what this array list would be storing? As you can see that I created with the help of the new keyword, I created an empty object, and it would store all the map dot values that, or you can say that the all the values that a map is containing. Now, the map contains, as I told you, map contains values like maintains its value like key and value pair. So each key like let me show you like this to now imagine this column belongs to all the keys inside the hash map and this column belongs to their respective values that are associated with their respective keys. Now it means that one is arriving inside the array two times, two is arriving inside the array one time, and three is arriving inside the array four times. Now I am creating an array list which would consist only of values inside that are available inside the hash map. It means that my list would contain only values which are 2, 1, and 4. As you see that these are the values inside the hash map. So it would create a new array list which would contain only the values that are available inside a hash map. So after the hash map is created like this, I simply use collections.sort ls, which would sort the array list in the ascending order, which means that the frequency for the least arriving element or the least number of elements or quantity of number of elements would be at the first index, and the element that is and the frequency for the element that is arriving the most would be at the last of the whole array. Now after that, I first calculated the size of the whole hash map. It means that I am first getting out the different types of arrays, sorry, different type of integers that my array that I was given includes. It means, as you know that different type of integers first created its own key, and their values, the values associated to those keys stores the frequency of those characters or those elements. So if we find out the size of the whole hash map, it would give us the total number of different unique integers inside the inside the array that are currently present before any k removals or before any removal of any element. Now after that, what I did, I simply iterated through each and every element that is present inside my ls. Now remember, the ls is the array list that contains the frequency of each and every type of integers inside my array. Now what I'm doing is that I'm removing the least frequently occurring one. Now, as I told you before, for us to get the least occurring least sorry for us to get the least or unique least number of unique integers after the k removals, we need to remove the least occurring numbers so that the rest of the space is occupied by the most occurring numbers, the numbers that are occurring the most, and it would occupy most of the space. So that's why the we would get the least number of unique integers after k removals. Now I am simply comparing, and as I told you, this is a for loop and it would iterate through each and every element through of ls. So and would represent the frequency of each and every element after each iteration. So it would first check if my n is less than or equal to k. After that, if it is less than or equal to k, it would minus the length and then update the value of k. Now, what is happening over here? Let's dry run it. Okay. Now, for example, we have after the array is sorted, we have something like this. Okay, and the value of k, let's imagine the value of k to be 4. Okay, now what is happening over here? Now let's take it 3 just to shorten it up a bit. Now, as I told you, this array list represents all the frequencies of different type of integers. So we can assume that this one represent a unique integer and it is coming one times. This two represent another unique number and it is coming twice in the array. And this element represents a different unique number and it is coming thrice, and the last one is coming for 4 times. Now what I am doing is that first it would go to each and every element. So n first would come arrive at n 1. So n represents 1, and as I told you, 1 is less than k. Now, this condition, what is does that? As I told you, that we can do only k removals. So, if for us to achieve k removals of the least frequently arriving element, the frequency of the element should be less than k. Because if it is greater than k, then we cannot remove all of the element at once, and it would not reduce the total number of unique integers inside the array. So that's why in this condition I've implied this applied this computation that the current frequency should be less than k. It means that we can take that whole category of that numbers and remove that from the array, which would reduce the unique number or unique integers from our array. So as you can see that n is currently less than k, so k is 3 and n is currently 1. So it would be removed from our array. Now n is equal to 2, and as I told you, the length would be minus as well. As I told you, length represent our size of the whole hash map, and we can also correlate it as the total number of unique integers are in our array. Okay, so the length would be the length is currently 2 4. Now it would be 3. Now n is equal to 2 and k is equal to, after updation command, this updation command, it would be equal to 2. Now again the if command will be triggered because n is equal to k. So we can say that we can remove two elements of the same time which are currently the least frequently arriving ones, and it would reduce the total number of different types of integers in our array. Because if we remove two elements that are two elements from the integer of the integers that are coming thrice, then it would not reduce our unique integers in our whole array, because it would be like this, and the total length would remain 3, and as you can see that the least number of the unique integers inside the array after k removal would remain 3. So to reduce the different type of integers in our array, we will remove the element that is less than or equal to k. So it would remove 2. Now n is 3, and now because we remove two elements of the same type, so now k would be 2 minus 2 is equal to 0. And as we know that we removed an entire category of a integer, so the length of the hash map would also be reduced, or the length would be reduced because the we can relate the length as a different type of integer. So now length would be equal to 2, and n is now currently 3. So and k is equal to 0. So we cannot further, as k is equal to 0, it means that we cannot further remove elements. So now the final answer would be, as you can see that there would be only 7 elements inside the whole array left, and it would be of only two types. So the answer would be 2 over here. And after that, the whole loop will learn like this, and after that, I would return the length as the answer. Now, let's simply run the code. Okay, so you must have seen that I've already passed the test cases. So now I'm simply submitting my code to further test my code with different test cases. as you can see that my solution has been successfully submitted and it beats around 79.17 of the users. Now, again, this is not the most optimized solution. There are more optimized solution and I have gone through them. But this is the most easiest one to understand. And for the purpose of understanding this whole solution, I use this solution to explain to you all. Now coming to the time complexity of this whole array. The time complexity of this whole array would be dependent on two things. First, the number of iterations the for loop is taking, and then the most important things, the number of time the collection dot sort took. So, the number of iterations the first for loop took is n, so the time complexity would be of n. After that, the collection dot sort took the time complexity of n log n, that is the default time complexity of the sorting algorithm. And also the for loop would go to till the size of the array. The most dominant factor inside the whole solution code is the sorting algorithm. So the total time complexity of this whole code would be n log n only. Well, that's all for the today's three questions solution video. Thank you for watching.